Okay, hello everyone. Thank you for attending this presentation. Uh, Today, as part of the Wired Wednesday seminar series, Alireza is going to present his research. Alireza is a graduate student working under supervision of Dr. Hamidreza Zaripur, and he's going to talk about uncovering wildfire smoke role in solar power losses in Alberta. Sorry, Alireza is working under supervision of Dr. Zaripur and Dr. Fah from
Yeah.
Department of Electrical at the University of Calgary. Thank you. After his presentation, we will open the floor for your questions. Thank you, everyone.
Thank you, Fatima, for the introduction. As Fatima mentioned, I'm Ali Reza, I'm master's student, University of Calgary, and working with Dr. Farah and Dr. Zaripur, and also Dr. Mustafa Farokhabadi. It was a great chance that I had a chance to working with all of you. And I wanted to mention that this is not final result of my research. This is an ongoing work, and I just wanted to share what I have done so far and to give you some insights about the research. So I'll try to wrap it up in like 40 or 45 minutes, and then we can have some time for question and answer. And just let me share my screen. Can you see my screen?
Yes.
Yes. Yeah. Before I wanted to start the motivation or the goal of my research. I wanted to give you some insights about the topic. As I mentioned, the topic is about uncovering wildfire smoke rolls in solar power losses in Alberta. So my focus was specifically in Alberta, and I had some insights on my work I would like to share. And before going before um, talking about the research topic, I wanted to give you some statistical information about the wildfire and solar farm in Alberta. As you can see, Alberta solar capacity remains flat, like 50 megawatts from 2017 to 2019, and it had a sharp increase began in 2020 to 107 megawatt, and but by 2023 the capacity surged to 1.6 gigawatt, and over like 15 times growth in just 4 years. So this shows that rapid expansion is in using solar energy in Alberta. And this is a timeline that I plotted. It shows the each solar farm in Alberta began operating um, uh, and covering period of 2018 to 2025. I think the first solar farm started like before 2018 or something like that. And we observed that sharp increase in farm activity starting around 2021, and aligning with the Alberta solar capacity boom. And many farms became operational during wildfire heavy years. That's the reason that we really need to take care of, like, study more about the wildfire impact on solar energy. And this timeline guided me for data selection, helping to find the coverage that we have in each solar farm, and for data collection, I mean. And this is also a spatial map on this map shows where solar farms are distributed across Alberta. So you can see that we have strong concentration in south and southeast, and some farms are close to major cities like Calgary, Edmonton, Red Deer, but many of them are located in rural and remote areas. The thing is that I wanted to mention that the challenge that I had with this distribution was that I wasn't able to, to collect data, weather data for some rural areas, because weather stations are mostly, located um, in city areas, like so. So I had to have some kind of station mapping to find and filter the solar farms that are close to these weather stations. These are some key projects in Alberta. As you can see, actually, right now, Traverse Solar Project is the biggest one. Yeah, Alberta is home for some of most significant solar developments in Canada. So Traverse Solar Project is currently the largest in the country and is powering around 150,000 homes. And Biggest Sky and Summits also are really big. And Summits is just started, I think, in February 2025 with 75 megawatt initially, but it's the goal is like 325 megawatt, and it should be really bigger than Traverse one. And these are some insights about wildfire smoke in Alberta. As you can see, this chart shows that total hectares burned by wildfire in Alberta from 2019 to 2024. 2023 was extreme outlier with like something 2.2 million hectares burned, and is really far above the average. And we also have like we exceed the average in 2023 as well. Sorry, 2024. Um, and mm, it's it shows that we will have uh, prolonged smoke events after happening these wildfires. I also have another chart that shows monthly wildfire count. This is just count. We had a data set of recorded wildfires in Alberta. So as you can see, this is starting from 2018 again to 2024. I started um, this timeline, but I will explain what happens later. So, wildfire activity consistently peaks between May and August, and July 2023 standing out. It was a really extreme case, and the chart shows that how we have wildfires on early spring, like April, May, and some of them are, and also midsummer, like July. They are like kind of critical points. But the summer, actually, the wildfire season is starting from April, May, and finishing by September, and we have some few maybe wildfires in October, but not much. And this is also a heat map that shows the wildfire density. Um, Most of this I plotted this heat map based on the wildfire records and the wildfire sizes, because I also had the size of the wildfires, and this shows that along the BC and Alberta border, uh, we had most of the fires, and interestingly, solar farms are a little bit far from these locations, so they are not near to wildfire to be affected. But this diagram is a little bit misleading, uh, because the wildfires are not really the most important part, because the fire, we need to study fire smoke, not wildfire. So I didn't use the wildfire records for smoke detection or something, just for confirmation that this is smoky because the wildfire happened around the city. But I wanted to say that solar farms don't need to be near to wildfire to be affected, because smoke can travel hundreds and sometimes thousands of kilometers, and many smoke events in Alberta originated from some fires in BC, not in Alberta, and some fires in maybe Washington or California, or even California. So the point is that we really need to focus on fire smoke, not wildfire, because this is the reason that generates PM 2.5 and air pollutant and reduce the solar energy production. Let's back to the research. So the problem statement I have written is that wildfire smoke always reduce solar energy output by blocking the sunlight. But as you know, we also have other modifiers that block sunlight, like cloud cover, or blocks solar panels, like solar snow or soil, or also some other modifiers like temperature and wind. That high temperature can reduce the efficiency of solar panels, and wind can increase the efficiency of solar panels. So this interplay, interaction of the weather variables makes it difficult to isolate the impact of wildfire from the other factors. And this is the main part of the research. So we really need to focus on isolating the smoke effect from the other modifiers. Like, we also may have some infrastructure failure on solar farms. So we may need to collect the failures in solar farms. They collect the data to be able to to specify that these reduction are because of the reductions are because of infrastructure failure. And the problem is that most current solar forecasting models, especially those are integrated in grid, are not accounting for smoke. I wanted to emphasize this again, that solar is integrated to the grid. So and the uncertainty part of solar, actually renewable energies like solar and wind, is that can in a stable can change the stability of the grid. So this is the problem that is the final issue that will happen after extreme events like solar fire, like fire smoke and so on, and these prediction errors will have impact on solar, as I mentioned, grid instability, and will need some and the other and consequences are some kind of unnecessary curtailment or overcommitment, or using unnecessary storages or reserve capacity. And solar, and I also wanted to mention that smoke patterns can change rapidly over duration of time and location. They can travel quickly, they can change day by day and hour by hour, and it makes this forecasting prediction really difficult. Um, yeah, the motivation is that just with accurate solar prediction, we can have a stable grid, because solar is integrated to the grid, and we can match supply and demand with an accurate prediction. And weather forecast can help with backup generation. We can consider curtailment if needed, and we can optimize energy dispatch. And and modeling this impact of fast changing smoke um, can improve the reliability of the grid, and understanding the smoke effect also can be used to for investing the new solar farm, that for siting the new solar farms in the country. And yeah, that's actually the motivation. And this is the research question that I designed. Like, it is, how can we, accurately identify and quantify the impact of solar energy on the impact of wildfire smoke on solar energy, and separate it from the other influencing factors like cloud cover, temperature, snow, wind, and so on. And the objective and the end goal is, building a model, building a tool to adjust the existing short-term solar production forecast during wildfire smoke forecast data. So we do not forecasting fire smoke, and we do not, sorry, just one moment. And we do not forecasting solar output directly. We are gonna to apply smoke forecast on solar forecast and modify the baseline solar forecast to see this is the impact of wildfire smoke. And the time horizon is so I'm not sure we can build a generalized model to apply for other solar farms or other countries, but this can be a goal, but I'm not sure that is achievable. And I also wanted to mention that we have different type of time horizons for forecasting, for solar forecasting. We just focused on short-term forecasting, not very short-term. We also have some kind of very short-term called no forecasting, which is related to 5 minutes to an hour. But we are just focusing on next day or maybe next 2 days, which can be called a short time horizon. I wanted to say that we also have mid-term and long-term forecasting for solar under wildfire smoke, but it's for some kind of long-term planning and decision making, but it is a little bit challenging, especially when we wanted to work on a long-term plan, long-term, because is it has a lot of uncertainty, and we can say that it's difficult to have a accurate forecasting. For no forecasting, really very real-time forecasting also is again challenging, because we need to have some real-time sensors and like for identifying the weather changes and smoke changes. This is also really challenging. And the final goal is designing an end-to-end application to see and visualize the impact of wildfire on solar production, on solar forecast, and provide it as an API to be able to integrate in operational systems. This is a workflow for my work, end-to-end workflow. I started, I started with, I worked on the range of 2018 to 2024, and the scope was Alberta. I started the data collection. Data collection was hourly data. I focused on solar output and weather data. I collected all solar output generation hourly average, like in megawatt per hour. And I also collected some other environmental variables from different data sources, and the variables are cloud cover, weather conditions, temperature, humidity, PM2.5 CO, monoxide carbon, air quality health index, and wind information, and so on. After collecting data, I did some pre-processing. I handled the missing values. I converted timestamps to UTC to make data consistent. I calculated the blue sky irradiation. I worked on the direct irradiation, and to be able to to calculate the potential output of a solar farm and compare it with the actual one, and to see how much it has been dropped, considering that we have some drops, seasonal drops and hourly drops, so we really need to see the capacity of solar generation. And I did a station mapping. I explain it later. It's for mapping solar farm with weather station, because weather station are not necessarily close to our solar farm. I did some data integration and merge, and created a single file, master file, including all solar generation and weather data. And for the modeling part, I did smoke event detection to find the scenario that they were really smoky, because we cannot, just for some cities like pollutant, some we cannot rely on PM2.5 only and say that high value of PM2.5 shows that it's smoky. But in Alberta maybe it's different. I will show later. And I use the other air qualifier, like CO, air quality of index and visibility, to confirm and overlay on PM2.5 to find the smoky days. I cross-check with the news report, the smoky days, and label the data. And the final part that I'm working on is prediction and also interactive application development. This part is not completed. I don't have anything to show today. It's like feature engineering, or use statistical or machine learning model for prediction, and build an application into an application to provide an API and download or visualize and so on. And I want to just have a quick overview on my data sets. Solar production is used for collecting the solar output. So I had the value, hourly average solar production, and I also calculated blue sky radiation is something that I have calculated. I also collected the max capacity from ISO website. I also found the location of solar farms myself, so it was like a little bit tricky to find the solar farms, all solar farms in Alberta, and collected weather data from different sources. I was looking for cloud cover and found weather source as a reliable data source for cloud cover. I made some correlation to see how data is accurate, and it was really good. And I also had some other, weather data in weather source, but also, use these from the other data sources as well. And I collected weather data mostly from Environment Canada with 3 data sources. The first data sources is for the weather conditions, like temperature, humidity, wind information, visibility, and weather condition, and PM2.5 and CO for pollutants that and uh, and also I use weather stat for finding health index. Health index is really important, indicator to see if the weather has some, maybe smoky or haze or something. And I also collected all wildfire records from Alberta CA, but this is not it's just used for some kind of confirmation, because we need to focus on, as I mentioned, need to focus on fire smoke, not wildfire. And for data processing, I did some handling missing values, converted timestamp to UTC, check data completeness, check invalid extreme outliers, and standardize the column names and drop the duplicates, and also calculate the daily average. For calculating the blue sky, I'm just following the step that I showed you in my end-to-end workflow. So I'm just trying to follow the steps here. So after pre-processing, I calculated the blue sky radiation. This is used for normalized solar output across different times and seasons and locations. And you know that the solar output can be changed in, with different values in summertime and wintertime, based on the condition. And calculating the blue sky radiation can help us to find the theoretically maximum solar radiance in the blue sky condition. That is not cloudy, not smoky, not hazy, and enable us to have a comparison between the actual output and expected potential. I use PySolar. This is a library, Python library, to calculate based on time step and location for solar positions. The next section was station mapping. As I mentioned, I collected data from different sources. For solar farms, it was I had 43 solar farms across Alberta, and for PM 2.5, I had 26 stations. For CO, I had 24 stations. For air quality health index, I had something like 28 stations or something. And the stations were different and different locations. So I had to match weather with solar output to see each farm must link to nearby stations. So this was kind of, I visualized it with Python to find, the nearest one, and I exported the output, the CS file, and I saw that a lot of, solar farms are in urban areas or rural areas or far from weather stations. So we cannot use the weather station which is not close to solar farm. I was also looking for finding maybe weather station from the solar farms, but because of I don't know, it's the companies are reluctant to share their information because it's a competitive market, and I wasn't able to to obtain the weather information specifically for the specific solar farm. So I had to use the Canada environment weather stations, and the result was that after mapping, I had to filter, as I mentioned, because some weather stations were far from my solar farms. The result was filtering out by the distance of 30 kilometers for all weather stations, and the result is that I just could keep 8 solar farms out of 43, and those are mostly close to the cities. So they are, they are in Edmonton, Red Deer, Calgary, Lethbridge, and Medicine Hat. After station mapping, I did some data integration to have a master file. So I used station mapping result to join solar output with nearby weather station and air quality data. So merged all multiple data sets as a single master file, as time series file, and started just analyzing the master file. And the result is a unified data set. Each row contains solar output and all environment variable and timestamp and also the location, and longitude and latitude. The next step, which was really important to me, was smoke detection, smoke event detection. As I mentioned, considering PM 2.5 is not enough for finding the smoky days. So I did some steps for aggregating data and doing some normalization to be able to, to find the smoky detection. I used quantile percentage, like 19th percentile for PM2.5 to find the high values of smoky days, to be able to find the scenarios. As I mentioned, for modeling, we need to find some scenarios. In the simple way, we need to find the scenarios that are smoky and non-smoky, can bit value, or they can have a range value starting from 0 to 1. But I am considering to find some scenarios to be able to, to separate, to isolate the impact of wildfire. So I am looking for finding some scenarios like having smoky days, without cloud cover or without infrastructure failure or without any other modifiers, and having some non-smoky days, again, without the other modifiers. So my goal is to find some scenarios, specific scenarios, isolated scenarios that would be really great achievement. If I can't do it, I'm just working on it. So this is some kind of, initial analysis. And after identifying the high values of PM2.5, I overlay the other indicators like air quality health index, CO, monoxide carbon. And I didn't mention that monoxide carbon can be used for, because when we are burning a wood, it's generating monoxide carbon. So it's a good indicator to confirm or use for our feature selection. I use these overlays for confirmation. I also did some kind of manual event, like using manual event like news and reports, public reports, to confirm that this period of time was smoky. And finally, I labeled, the confirmed smoky days for analysis. This is the first report that I had. As you can see, this is only for a specific solar farm, which is Barlow's Solar, and it is for only for 2023. I did the same analysis for different years and different solar farms. I'll share the result. And as you can see, I normalized some data like CO, health index, and visibility. Visibility is like how many kilometers we have visibility. It is a good indicator to see if it's a smoky or hazy. And there's also a smoky reported. A smoky reported is we have a weather column in Environment Canada data that shows that it's a smoky, hazy, or something, but they are not, reported completely. I just have it in one of the solar farms I'll show you, but as it's not completed, we cannot use it completely, and you can see the numbers highlighted over the PM 2.5 trend are the day numbers. So we have 16th May started with a high value of PM 2.5. It was like 80 milligrams and it increased the next day, and we have for a period of time, like a week. On May, I found a news. This is specifically for Calgary, but it happened for the other cities. I'll show you the result. But when I click on this is the news that happened. This is Calgary, and it's like 16th to May 2023. We had smoky days, and we can confirm that that was a smoky. This period of time was smoky. I also did the same, so found in City News that July 13 started a smoky days, but as we see in the pictures, it was not like the previous one, was a little bit better. And we also had the same in early September, like it's September 4 started from September 4, and September 5th and 6th also is included. And I found this in global news. This is, a video is included, and they discussed like the problem happened in smoky days. It was really smoky on September 2023. I can remember because I was at home the time. And this is I just wanted to share more results on my Jupyter notebook. So to see what happened in the other cities in the same time. So this is specifically Calgary that I showed you is 2023 Barlow's solar. And as I mentioned, is on May, July, and September is highlighted. And if I scroll down, you can see the same in Medicine Hat, right? So in Medicine Hat, we had the same impact on and I wanted to show you that this line is visibility, and you can see that the visibility was really low in this period of time. And the health index was not really good, was high, and also CO was high. CO is blue line, health index is green line, and visibility is orange one. And it shows that it was impacted by, as I mentioned, based on the news that we had, it was impacted by smoky events. And we had the same impact on Medicine Hat. Medicine Hat, we had impact on the same period of time. Again, May, July, and early September. And this is for 2022. Let's skip this one. This is for 2023 of Lethbridge. And this is the Lethbridge, right? Lethbridge, we also have the same impact on May, mid-July, and also early September. We also had another impact on in August in Lethbridge. I'm not sure I found any news for that time. I documented all here. So this is September 4th. This is May 4th in Lethbridge. May 16 in Lethbridge. This is August 31st in Lethbridge. So Lethbridge also had another smoky days around here. I don't know, this PM2.5 is 17. I need to check it. But yeah, this is the same. And if we check other solar farms in Red Deer in 2023, this is 2023 for Edmonton, and for Red Deer, this is for Red Deer. For Red Deer, as you can see, we have the same mid-May, mid-July, and early September. And in Edmonton, also we see the same in 23, May, mid-May, mid-July, and early September. And this shows that we can identify, the impact of the smoky days by PM2.5. I also wanted to show you this diagram, which is for 2020 in Red Deer. And we had also smoky reported by Environment Canada, but this was the only place that I saw that have smoky reported in data by Environment Canada. This is only the smoky days reported by Environment Canada in data, so we cannot rely on that. And just showed in the diagram that this is, also reported by Environment Canada and can be definitely considered as smoky days. And yeah, I also had this one. This is in August, like 16 or something. Yeah, we have some PM2.5s here in 2020 Red Deer. I found the news that was in a fire in the city, so it was not wildfire, but we had the news on fire, in cities and generated some PM2.5, had some impacts. And yeah, let's back to the slides. So yeah, I also wanted to share some impacts of I try to overlay the PM2.5 and cloud cover over solar output. This is specifically for Barlow in 2023. As you can see, we have PM2.5 solar output and cloud cover, but we cannot definitely decide on, see the the impact of PM2.5 on solar output. For example, in this place that was May 16 in 2023, we had some the green line is solar output, so we cannot see much like we cannot um, um, judge solar output deduction based on PM2.5 or the other places. But if you look at the behavior of cloud cover and solar output, you can see that cloud cover remains dominant factor in solar variability. So when we have a high value for solar output like this place, we have low value on cloud cover and vice versa. So this is high value on solar output and this is low on cloud cover. And here this is a peak on solar output on cloud cover, and this is a drop on solar output. So we see that we have uh, a strong correlation between cloud cover and solar output, but we don't have a strong correlation between solar output and PM2.5. This is also another insight that I had from my research, and the reason that is really important to take this into the account that we need to take care of cloud cover. So this is some other diagrams on impact of cloud cover and PM2.5 and solar output. As you can see, when we have high values on cloud cover, we drop, the solar drops lower values and vice versa. So it has a really great, correlation with cloud cover and makes it for complex and important to separate the other modifiers, specifically cloud cover and other modifiers as well. And yeah, that's all I am. I wanted to share with you. This is future work I made research. So I am working to build a model and develop an application to adjust the short term for solar forecast based on smoke and environmental data. I have a plan to also integrate satellite-based aerosol optical depth (AOD) from NASA to have a better accuracy on smoke detection. Based on some literature review that I had with Dr. Mustafa, I noticed that it's really important, to improve the accuracy. It's important to use both satellite and ground-based data together to get better result. I also wanted to use UVC fire smoke forecast to improve the accuracy or use it for building the model. This is also on my plate, and I had some issues with open biases framework. I didn't do that, and I don't know. I will work on this part soon. And I wanted to explore statistical or machine learning model for any, I'm not sure which can be used to find the best model to predict the output based on the input of fire smoke and environmental variables. And we need to deploy a model as an API, interactive app maybe, and this is the final goal. And we yeah, we can have like improve the model to support the real-time solar forecast as well. Yep, that's all. Thank you.
Okay, thank you, Alireza, for great presentation. Just for students and the researchers in this meeting, please welcome to ask your questions. Dr. Ronald Essa, please go
Great.
ahead.
Yeah, thank you. Great talk, very thorough, impressive. So
Thank you.
congratulations on a fine piece of work. Um, I'm guessing that once you perfect it for Alberta, you want to extend it over the whole Western grid if you can. But one of the things I'd recommend is that a lot of the long distance smoke transport is from elevated smoke plumes. Smoke plumes for which there's not high concentrations of smoke or PM at the ground. And also be aware that various reports that you're using, like visibility, that's horizontal
Yeah.
visibility near the ground, are blue sky forecasts of PM 2.5, that's at ground level. So
Yeah.
your plan to make use of the satellite optical depth is good. There are also ways you can get forecasts of the smoke aloft, which can be substantial and can be thick and definitely affects solar power. Um, our blue sky forecast system does forecast the smoke at all levels in the atmosphere. We only output the
Yeah.
smoke at ground level because that's our current sponsors. That's what they're paying us for. So my colleague Roland Shigas might be able to tell us, if we needed to output smoke at more levels in the atmosphere, um, how difficult it would be. And yeah, one of the reasons we don't do it, it takes so long to output these files in Blue Sky that it actually delays the forecast. And since we're doing real-time operations, you know, we have the need for speed. So
Yeah.
that's it for me.
Yeah, thank you. Thank you for your great yeah, feedback. I appreciate it. And yeah, for your point about, considering the other parts, areas, yeah, I also have a plan, to take care of it. And for the project that we are working together, for building the bad dashboard, we also are focusing. We focus on collecting data from the other areas, like not only BC and Alberta, even like all of Western America and Canada, like California, Washington, BC, Alberta, and maybe North Territory and Territory. So yeah, thank you for your great feedback. I'll keep yeah, noted my yeah, your points on my research. Thank you.
Question, Ladan, please go ahead.
Oh, hi. Thank you, Alireza. It was a great talk. I just have a tiny question. About that fire heat map that you showed, it was a little bit strange to me that there was you said that those heat map are only from the wildfire event, not any urban fire at all.
No,
Because
actually,
yeah,
sorry for interrupting you. The heat map for fires are based on the wildfire records reported by Alberta government. So there is a open access like data set for all wildfires happened as not for is for all Alberta areas, not specifically for. But I mentioned that as let me
my
share my
my
screen and
my
go
question
ahead.
was, it was a little bit surprising that there was no fire around those solar farms. Is that a reason that they just suppress before it get there, or it is not any like a fire prone area around there?
Yeah, that's correct. Yeah, actually, the solar farms, the wildfire mostly happens in forest areas, like, near to Rocky Mountains and the border of Alberta and BC. But yeah, all solar farms are far from those areas. Based on my, I found the location of the solar farms myself. I think they are accurate. I didn't find any solar farm near to, those areas. So they are far, but, as I mentioned, this is misleading because, the fires can travel hundreds and thousands kilometers. They cannot be, considered.
Thank you. And I wasn't actually I didn't quite get that you use the weather information, and what type of input you're using. Are you doing the smoke detection on yourself, or are you using what is reported as a measure of a smoke from those weather stations?
Yeah, as I mentioned, for smoke detection, I use quantile percentage, like I use 90th percentile for high values of PM 2.5. And I cross-reference these values with other environmental indicators like health quality index and also visibility and also CO pollutant. And but eventually I cross-reference these with real news reported by, I don't know, in Twitter, all social medias and news, public news, to make sure that these are specifically um, um, from fire smoke. This is not maybe challenging for Alberta because we don't have as much, pollutant like vehicles or factories in Alberta, but it will be a challenge for the other areas, like, big cities, like for some cities, like for some other countries maybe. So PM 2.5 cannot be considered or any other air qualifiers cannot be considered only measures for detecting the smoky days. So they should be cross-referenced with some, news and maybe social media. This is a solution. There should be other solutions as well, but this is
Okay, thank you so much.
no problem. Thank you.
Okay, any other questions? Okay, thank you, Alireza, for the nice presentation. It was a great presentation, and thank you everyone for attending this presentation, and have a great day.
Thank you. Thank you.